So in this video, I want to review operations and content that has to do with fractions. Now, this is not actually technically 7th grade content. It actually has a review of what we did in 6th grade. The only thing that's new is what to do with those signs, but that's just the same thing we talked about in the previous videos. But I don't want what you're supposed to have learned in 6th and 5th grade to be the reason you're not passing the PFA. So I'm going to spend some time going over this anyways. Let's start with just reviewing what a fraction is in the first place. A fraction is a number that represents a part of a whole, or sometimes even slightly more than a whole. So for example, on technically a proper fraction, you're going to have a numerator that's smaller than the denominator, like this one here, 2/5, right? Is 2 parts out of 5. That's what that actually is saying. So that slash really means division. Now, an improper fraction is one where the numerator is bigger than the denominator. It's called improper fraction because it's not a fraction at all. It's like actually bigger than a whole, right? So it's as if you had 7 pieces, right, which are made out of thirds. So that's really the same thing as 2 wholes plus 1/3. And that's the other way you're writing that, as a mixed number. Now, there's a quick way to transfer between the two of them that helps a lot. The way you do it is you divide this top number here. If you're going this way, you're going to divide the top number by this number. So for example, 7 divided by 3, you can fit 2 in there. And then you write that outside. And then the remainder, you write next to it. So 7/3, you can fit 2/3, 2 sets of thirds, so 6/3, and then 1 more third, right? And so that's what this is basically saying. If you're trying to go this way, the method is you just get 2 times 3, right? And then add the 1 that's on top. So you're going to do 2 times the denominator. So you do the number that's in the front times the fraction plus the number that's on top. In this case, you get 7, of course, and then add the denominator, that's the 3 of the original fraction piece. So let's see a couple more examples of that. Let's say, for example, you had 8 6s. Right? Why would I do that with a mixed number? Well, that'd be the same thing as I can fit 1 set of 6s, and then I have 2 that I couldn't fit. So 2, 6, right? 1 and 2, 6, which is, by the way, the same thing as 1 and 1/3, because you can simplify this bit. But that's how you would do that. The other way that you could do that, let's see, 29/5. So 29/5 would be the same thing as, well, I can fit almost 6 sets, but not quite. I can fit 5 sets of 5s, which is 25, and I have a remainder of 4/5. So that's going this way. Let's do some practice going the opposite way. So let's say I have 2 and 2/5. So remember, the way you do this is this times this plus the top. So 2 times 5 is 10 plus the top is 12. And then write the same fraction on the bottom. So we just be the same thing as 12/5. How about 1 and 2/5? Or 2/6. 2/6. Let's do 2/6 just to change the number. Now let's be 1 times 6, which is 6, plus 2 is 8. We just did that. 8/6. Right? It works too. All right, so then this is how you convert between fractions types. And just so you know, I always like to do operations with fractions in this kind of format, not the mixed number format. Keep it in improper fraction or actual fraction when you're trying to create the operations that we're going to be talking about on this video. Now, I had to go back and insert this part of the video because I realized that I forgot to mention the basics, and I don't want to go ahead and assume that you know what they mean. So when someone says numerator, they obviously mean the top of the fraction. And then when they say denominator, they mean the bottom. And again, that symbol on between them, the fractional bar, is basically division. That's what that means. So really what you have is one number being divided by the other. And this usually represents parts of a whole. So the denominator essentially means how many parts you would need to make a whole out of this fraction. And then the numerator essentially means how many parts of that do you have. So for example, if you have 1/3, that means it takes 3 of those parts to make a whole. and I have one of them. Now, whenever the numerator is smaller than the denominator, like this example, you're going to get a number that's smaller than 1, a small number, because you're dividing a number by a number that's bigger than it. So you can end up with a small number. But whenever you have them to be the same, like for example, if I take 3 parts to make a whole, which is what the denominator is saying, and I have 3 parts, so if they are the same, then you're just dividing the same number by itself, and that means you get 1. So this just means a whole, right? And that's a normal fraction, that's just means a whole. Now, if you go above that, let's say, for example, you do 5/3, that's why it's called improper fraction, because you really have more than a whole, because you're dividing a number by a number that's smaller than it. So you're going to get a number that's bigger than 1. So that's going to be bigger than a whole, right? So therefore, an improper fraction, which you can, like we just said, write as a mixed fraction. In this case, it would be 1 2/3. Now, the interesting thing about this then is that what it essentially means is that every time you make the numerator bigger, so if you increase the numerator, what you're really doing is you're going to increase the number. So when you increase the numerator, you increase the number. But when you increase the denominator, or the bottom of the fraction, you're actually going to decrease the value of the number. So the bigger the bottom gets, while the top stays the same, you're dividing by a bigger and bigger number, you're making the number smaller and smaller. And the bigger the top gets, the number gets bigger and bigger, because you're dividing a bigger number by the same thing, right? So that's basically how fractions work. It's essentially division. It essentially means part of a whole, and that's essentially the basics of fractions. So now let's keep going from here. Okay, so the next skill that I'm going to talk about is how to multiply fractions. So to multiply fractions, it's fairly straightforward. You just do top times top and bottom times bottom, so long as they're in that format that I just talked about, right? Not a mixed number. So convert it out of mixed number first, and then you will never make mistakes. So in this case, you do 2 times 3, which is 6. 5 times 4 is 20. And there you go. 620 over 20 is your answer. Now, you could simplify this or reduce it, which means finding something that you can divide both the top and the bottom by. And it seems like in this case, they divide it by 2 to go this way, and then they're done. Now, sometimes you can go further. Let's say, for example, I was trying to simplify 24/12. What if I divided that by, say, 2? Then this would be 12/5, right? Can I find a number that can divide the top and the bottom by? No. But what if I did, let's say, 30 over 24. Let's do that. And I'm going to divide that by 2. So if I divide that by 2, I get 15 on top and 12 on the bottom. But I can still divide that by 3, because both the top and the bottom can be divided by 3. And so if I do that, I would get 5 on the top and 4 on the bottom. So you keep reducing it until you cannot find a number, a whole number, integer, that you can divide both the top and the bottom by, and then you're done reducing or simplifying. Notice, by the way, that in this example, if I had just divided by 6 all along, I could have gone from the start to the end in one swoop, because 30 divided by 6 is 5, and 24 divided by 6 is 4. And notice how interesting that 2 times 3, which is the 2 steps that I took, is 6, right? Because, of course, those are factors of 6. So that's kind of why that is. So I also showed you an extra skill here, which is simplifying fractions. But multiplying fractions is fairly straightforward. You just do top times top and bottom times bottom, and reduce it if the problem asks you to. But technically, 6 over 20 is just as correct as 3/10, unless the problem asks you to answer in the most simple form. How about dividing? How would you go about dividing? So you divide fractions by, there's different techniques. I like to use what's called the copy.flip method. And that is when you copy the first number, and then you change the sign to multiplication, and then you flip or invert the second fraction. These are called reciprocals, fractions which are the opposite of each other. They're called reciprocals because when you multiply them against each other, you get 1. But another way of calling them is inverse. So that's why it's called copy.flip, because you copy the first one, you change the operation to a dot or a multiplication, and then you flip the second one. Then you multiply like you normally would, like we just talked about. 4 times 3 is 12, and 5 times 2 is 10. So 12 tens is your answer, which of course is the same thing as 6 divided by 5. And you could simplify that no further, but you can also represent it as a mixed number if you wanted to, which is 1 1/5. I really don't like using mixed numbers. After 7th grade, you're going to find that that's not incredibly useful when you're trying to do all the operations you're going to do with the fractions. But it does help us realize that it's bigger than a whole by a fifth, right? 6/5. So it's not completely useless to use mixed numbers. So the division process is copy.flip. There is an alternative method that you could use here. So I'm going to show you that. Some people like this one, but I find that students make more mistakes when they use this one. So I don't like using this one as much. So the way you do it is you're going to start at the top and you butterfly it. You go down here, 4 times 3, and then you write your answer up here, 12. Then you start down here, 5 times 2, 10. Write your answer down here, 10. And there you go, 12 over 10, the same answer you got before. I have to remember is that I start at the top, go to the bottom, end at the top. If I start at the bottom, I end at the bottom, right? So you kind of crisscross and you got the same answer without having to rewrite much. And that's why people like it. But they also make more mistakes. So I prefer that you try copy.flip because you would probably get it right every time. Now, what I'm about to describe is an extra little bit, which I hope it doesn't confuse anyone. This is how you do it. You don't need to notice this necessarily this way, but there is an interesting pattern. Sometimes it's actually easier to just divide the top and the bottom. What do I mean by that? Look at this. 24 tenths divided by, let's say, 3/5. So let's say I do copy.flip here, all right? So I would do 24 tenths times, so copy the first one, then times, and you invert the second one, right? Now, when you do that, you're going to get 24 times 5, and that's a big number. That's like hard to do in your head, right? But in this case, it's 120. And then 10 times 3, which is 30. And you can actually simplify this a lot because 120 divided by 30 is actually 4. So this will become 4 over 1 if you simplified it. What I want to show you is an interesting thing. If you just do 24 divided by 3, okay, 24 divided by 3, well, that's just 8. And if you do 10 divided by 5, that's just 2, okay, which is 8 divided by 2, 4. That was a lot easier than doing this thing, right? The problem is that this doesn't always work neatly. It only works when it's easy to divide the top by the top and the bottom by the bottom straight away. Now, what if you don't get a whole number when you try to do that? Like, look, the original example we try to do. 4 divided by 2 would be 2. 5 divided by 3 is 5/3. It doesn't come out to a whole number. It comes out to a decimal or like a fraction that has repeating decimal. Doesn't work out. It's not as neat. Now, there is a way to get out of that and still get your answer, but I'm not even going to bother explaining because there's just more confusion. So which of these methods do you use? Well, what I do is if I notice that it's very easy to divide the top by the top and the bottom by the bottom, and it comes out to nice whole numbers, I just do that. If it's not, if I end up with like a weird fraction where the numbers don't divide into a whole number, then I do copy.flip. That's how I do it. But any of these would kind of work. So yeah, this fraction review is taking quite some time because there's a lot of skills. Remember, we spent a long time in 5th and 6th grade reviewing these skills. And we didn't even touch on the things that we learned new. The only thing I will remind you of that is that let's say this was a negative sign here, all right? Because this is negative and this is positive, the final answer would be negative, right? Because there's only one negative sign. If you had 2 negative signs, negative times negative is positive. That is the bit that is new in 7th grade. That's it. All the other skills that I've been talking about this whole video are just a review of things you're supposed to have learned before the 7th grade. Only the sign rules are supposed to be new. which takes me to the last set of operations involving fractions, which is adding and subtracting fractions. Now, luckily, subtraction and adding is all one thing. You do not need to actually learn something different for subtraction. You just got to remember that when you have to do the subtraction, you must first think about what you need to do with the sign. So, for example, let's say we're trying to do 1/3 minus 2/3, right? That is the same thing as slash the sign, change the operation, doing 1/3 plus negative 2/3. So that's what you're going to have to operate, right? So let's say we're doing 3/5 minus 2/3, right? So let's say you're doing that. Well, you have to change the operation sign, and you would do slash this to become a positive, slash this to become a positive. It looks like you have to do 3/5 plus 2/3. So if you're subtracting, you just got to make sure you change that into adding first, right? And then you do normal adding of fractions, which is what? So if you remember from 5th grade, when you have to add fractions, the most simple way of doing that is to first find a common denominator. Now, the common denominator is the smallest multiple that you can find that both of these guys have in common. But there is a shortcut that sometimes works easier, which is just multiplying the first fraction by the denominator of the second fraction. So you see how this is 1/3? So over here, I am multiplying 1/3 times 6 on both the top and the bottom because the other fraction's bottom is 6. Then on the second fraction, I multiply the bottom and the top by 3 because that's what the bottom or the denominator of the first fraction is. When you do that, following the multiplication rules that we just talked about, 1 times 6 is 6, and 3 times 6 is 18. So you have a new fraction, 6/18. And then 1 times 3 is 3. 6 times 3 is 18. You have a new fraction, 3/8. And now you can just put them together. Now remember, if they only put them together if they have the same denominator. And the easiest way to find the same denominator is to literally do this process, right? 3 times 6 is 18. The common denominator is 18. You multiply the first fraction by the denominator of the second one, and the second fraction by the denominator of the first one on both the top and the bottom. Once they have the same denominator, you just copy down the denominator, and operate the top like the denominator is not there. In this case, just erase this from earlier here so we can see it. In this case, 6 plus 3 is 9. And then you have 9/18. Now, of course, that can be simplified. 9/18 divided by 3 gives you 3/6, and then divided by 2, that gives you 1/2. So half is your final answer if you're trying to give it the most simplified version. Now, technically, 9/18 and half is exactly the same thing, so they're both right. But if they want the simplest answer in the problem, you can simplify it. And remember, you could have gone straight from here to here if you had divided by 9 straight away. If you divided by 9, right, that would have worked because we ended up dividing by 3 twice to simplify here. So that's the same thing as dividing by 9. So if you divide by 3 twice. So that's essentially the process of adding. Let's do one more example, except I'm going to pretend in this example that over here you have 2 sets of negatives. So instead of being plus, we're going to do minus 2/5. So we can actually practice the 7th grade skills. Notice again, you can multiply the first fraction by the bottom of the second one, and the second fraction by the bottom of the first one. And then you get new fractions when you do that, and then you're going to put them together. Now you have to do that with the same signs as the original. So negative, let's see, actually, when we slash the signs of the original, this should give us plus and plus. So it turns out that we would actually end up adding them together, right? So if you had 3/8, that was too small. I want to make sure that you can see what I was doing. 3/8 minus 2/5. That's the same thing as plus change the sign, plus, change the sign. So you ended up adding anyways. And then you do the same denominator for the final answer, which is 40. And then on the top, you do it like the denominator is not there. 15 plus 16 is 31. Final answer. There is a second method of finding the common denominator, which sometimes will give you a simpler answer, which is actually trying to list the multiples until you find the first multiple that they have in common. And you can see them doing that with this problem over here. Now, in this case, the common multiple turned out to be 40 anyways, so it didn't make much of a difference. But let's say you were trying to add 3/8 or negative 3/8, so we can practice 8th grade skills, minus 4/6. So you could multiply the top and the bottom of the first fraction times 6, and the top and bottom of the second fraction times 8, and then do it that way. But I'm going to do it the other way that you can do this to show you that it sometimes can also be useful, and you can do it whichever way you prefer. But first, I have to deal with the subtraction sign, so I slash that, and then I change the next number. So it looks like I'm adding negative 3/8 to negative 4/6. All right, so the way you do that with the other method is you're going to list the multiples, just like they do it over here, of each of the denominators. And I like to list them alternating numbers. Whenever one passes the other, I switch to the other one. So first, start with the first one. So I got 6 and 8. Then because the 6 is smaller than the 8, I'm going to go here next, and I'm going to write a 12. Now the 12 is bigger than the 8, so I'm going to switch up here and write the next multiple, which is 16. Then 16 is bigger than 12, so I'm going to go down here next and add 6 and put 18. Now 18 is bigger than 16, so I'm going to back to the top, and then 16 plus 8 is 24. Just make sure you remember how much you're adding to each line, right? The first line is 8, the second line is 6. You can tell by the first number. And then 24 is bigger than 18, so I'm going to go alternate back down. 18 plus 6 is 24. Oh, we found a common multiple between them, 24. Now we count the number of steps that we took to actually get to the common multiple. So it took 1, 2, 3 steps to get that with the one that had a denominator of 8. So I'm going to have to multiply the top and bottom of that expression times 3. 3, not 6, because I am doing this method, which is based on how many steps it took to get to the least common multiple, not just any common multiple, right? So if I use the 6, I'm going to get a common multiple, but not the least common multiple. All right, and then I'll show you what it means later on. All right, the same thing with the other one, except it took 1, 2, 3, 4 steps. So I'm going to multiply the top and the bottom times 4. Now I rewrite the problem with a new situation. Negative 3 times 3 gives you negative 9. And then 8 times 3 gives you 24. That is the most common multiple like we talked about. Negative 4 times negative 4, right, will give us negative 16. And 6 times 4 gives you 24, least common multiple. Then I just copy down the denominator, and I'm down to 24. And then I operate the top like the denominator is not there. So I just cover this up in my mind. I do negative 9 plus negative 16. They're both negative, so I'm supposed to put the numbers together. 16 together with 9 makes 25. But since I have to keep the sign of the biggest, which is the negative, both are negative in this case, so it's obviously going to be negative. You make a bigger negative number, negative 25 over 24 is your final answer. Now, how is that different from having done this the other way? So I'm going to show you that sometimes it does matter. So if you had done it the other way, remember, this is the original problem in pink over here. I would have to do negative 3 times 6 at the top because I'm multiplying by the bottom of the opposite fraction, and 8 times 6 plus negative 4 times 8, which is the bottom of the first fraction, over 6 times 8. All right, so after you do that, you get a little bit, you are going to get a new problem, which is negative 3 times 6, which is negative 18, over 8 times 6, which is 48. Now notice that you're getting twice what you got before here. This is an 18 instead of 9 and a 28 instead of 24. But that's okay, because they're actually proportional, so it's going to work out at the end. Negative 4 times 8 equals negative 32. Pardon me. And on the bottom, you got 6 times 8, which is 48 again. Now, when you put those two together, guess what? You're going to get negative 50 over 48, right? So your final answer, denominators stay the same. So it would be 48. And on the top, you would get, both combining those two numbers because they're both negative, you get negative 50. Now, this is twice as much as this. So if you divide both the top and the bottom by 2, you're back to your same answer. But it was a lot harder because I was working with bigger numbers. So the difference of the second method is that when you do it that way, you're working with the least common multiple, which usually makes you not have to simplify at the end. That's it. But if you use the first method, all you have to remember is that at the end you have to simplify, maybe, if the problem asks you for it. And that's the skills associated with fractions. There was a lot. We talked about what was fractions in the first place, what was a proper fraction, what was an improper fraction, how to convert between the two from a mixed number to an improper fraction. Then we did multiplication. We reviewed how to simplify. We did division in 2 different ways, actually 3 different ways if you count the divide the top and the bottom way. Then we did adding with the common denominator in 2 different ways. And I reminded you that subtracting is the same thing. You just have to worry about the signs the same way you would with the normal operations. Now, this is a lot, but it's not really a lot of new things because all of this is supposed to be things you've learned about before. All right. Hope you found this helpful. On the next video, we're going to have something similar, but with decimals.